Hello and welcome back to my channel Code with Ease. Today we are going to solve this question sorting an array of zeros, ones and twos. This problem does not utilize any existing sorting algorithm, but we have to write our own custom sorting logic to rearrange these elements in a given order. It's a very popular question which is asked in several companies. Apart from that, it utilizes a very special algorithm called the Dutch national flag algorithm, which we are going to learn, and then we are going to learn how we are going to use this algorithm to solve this. But before that, as usual, we always start with the brute force and then gradually move on to the optimal solution. So with that, let's begin. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem-solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy-paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. So in this, we're given this array of size n, which consists of zeros, ones, and twos. We have to sort the array in an ascending order. It contains all these three integers, and first they're putting the zeros, followed by 1, followed by 2. Normal sorting in ascending order, if we just use any kind of an inbuilt function like arrays.sort and then pass in this array, it is going to give us this output. The requirement of the problem is very simple. Simply we have to sort the array, but the only catch over here is we're not supposed to use any inbuilt function. We have to write our own custom sorting logic. So in that way, it becomes very essential to know this problem because apart from being asked in several coding interviews, we also learn how to write our own custom sorting logic. So the expected time complexity is order of n, space is constant, and these are the companies in which this has been asked. So it's a very frequently asked questions in many of the coding interviews. So with that, now let's move to the whiteboard to understand how do we solve this. So here's the sample array that I have taken, and this is the time and the space complexity that I have noted. So first of all, let's talk about the brute force way. As I told before, this is a very special sorting question that we are doing, and we are not supposed to use any built-in libraries. So we are not supposed to use any built-in library. That is why we write our own custom sorting logic to solve this. Now, okay, fine. So if you are not supposed to use any built-in library, now if you have to think of some other way of sorting this such that we get all the zeros at the beginning followed by the ones and the two. So the output also I will be writing. So it should look like 0, 0, 0. There are 3 zeros followed by there are 3 ones and there are 2 twos. So this is what we need at the end. Let's try to think of the brute force way of solving this. We have 3 different integers and we want to place integer 0 at the beginning followed by integer 1 then followed by integer 2. You know that every integer is occurring for a finite number of times, like 0 is occurring 3 times, then 1 is also occurring 3 times, and then 2 is occurring 2 times. So if we can use some kind of a counter to track how many occurrences are there, once we know that, like how I wrote this output, there are 3 zeros, so I placed the 3 zeros. I placed 3 ones because there are 3 ones. I placed 2 twos because I can count there are 2 twos. So this kind of an approach is called counting sort. We count how many numbers or elements exists in a particular data structure, and then based on the count of that, we are going to rearrange the array or place them in its correct position. So this is called counting sort. So when we are trying to do this in the brute force way, first of all, we can think of how many times it is occurring, maintain a counter for every element like count of count underscore 0, then count underscore 1, and then count underscore 2. Then we'll use one loop to traverse through this and populate each of these counters. Once we are done, then in the second loop, some kind of a while loop or something, in that we will simply make use of this counter. So let's say if count of 0, in this case like it was 3, count of 1 is again 3, count of 2 is 2. So from 0 to 3, 0 index to 3, we should have all the zeros. Then from 4 to we have 3, so 4, 5, 6. So from 4 to 6, we can place all the ones. And at last we have like 7 to 7, 8. So 7 to 8, we can place all the twos. That's it. Actually, it will be 0 to 0, 1, 2. So 0 to 2. 3, 2, 3, 4, 5, and then 6 and 7. So if we go by the index values. So basically, we are just making use of these three counters, and accordingly, and then we are running another loop to put all the elements in its correct position. So that is what is going to be our brute force way, because that is what is the next way of thinking if we are not using any kind of a built-in library. So that wraps up our brute force approach. Next, coming to the actual algorithm that we want to learn, that is called the Dutch national flag algorithm. So the Dutch national flag, why does it name so? Because so whatever is the Dutch national flag, the flag of that country, they have three different colors. And this was given by some scientist. I'm not able to recall the name of that. What he basically wanted is, there were three different balls of like three different colors, and he wanted those to be rearranged in such a way that maybe it was red, blue, and white, something of that. So he wanted it to be rearranged in a way such that the adjacent balls should be of the same color. Like the red should be placed before, followed by the blue balls, and then at last the white balls. I'm not exactly correct about the ordering, but something of that sort. So this is why this question is also known as sort colors on lead code. I'm going to link it up in the practice link also in the description, so you guys can check that out also. So this is the basis of this algorithm. The scientist wanted to sort three different colors ball and place it in such a way so that the adjacent balls are of the same color. So from that context, this is the algorithm that is coming. Now, how we are going to make use of this? We have three integers, 0, 1, and 2. Think of it like three different colors. So what we can do is, we can use three different pointers, maybe I, J, and K, to track these. And then we can try to rearrange those. Before doing that, let us try to understand what exactly we are trying to optimize. Using a fancy naming algorithm is not the way to optimize a solution. First, we have to try to understand why at all do we need this algorithm. What was the problem that we faced in the brute force algorithm? So coming back to this, in brute force algorithm, we needed to do two traversals. First, in the first traversal, we were populating each of these counters. In the second traversal, we were filling in these positions with the respective integers. So we were doing two traversals. Now, when we are trying to optimize any solution which involves more than one traversal of an array, so it's usually asked to try to optimize by reducing the number of traversals. So our requirement is, we have to try to solve this by doing it in one traversal, in a single traversal. And from this requirement comes this special algorithm, Dutch national flag. Dutch national flag algorithm is going to help us in optimizing the solution, because instead of doing two traversals, now we are going to do one traversal. Simple. How? Okay, coming back to this example. So we have three different integers, and we are going to track each of them using three different pointers. So what we will do is, if we have to solve this in one traversal, I'll just copy this array, whatever I wrote above. So what we are going to do is, this I, J, and K, let's say I is going to only track this integer 0, J is going to track everything, J is going to track the integer 1, and K is going to track the integer 2. Why have I placed it in this order? K will be at last because it is tracking 2, and we need 2 because it's the largest element to be at the last. I is tracking 0 because we want 0 at the beginning, and J is like the middle element. Is what are we left with? We are left with this integer 1 itself. So that is the logic that we are following, which we are actually deriving from that algorithm. Now let's see how can we put it into use. What we will do is, what this algorithm suggests, firstly use these three pointers to track the three different integers, to track the three different integers. Now what we will do is, let's say I start with this pointer I. Whenever I come across any element which is a 0, okay, I will swap that with I. So J is going to be the pointer which is actually going to do the traversal. We can think of I and K as initially being static. So J is actually going to do the traversal. So I will be set to 0, K will be set to the ARR.length -1, whichever the last index is, and J will traverse. So what this algorithm will do, we will check if ARR of J, that element, whatever it is, if it is equal to 0. If it is equal to 0, swap I and J. Why? Because I is initially 0. I is supposed to keep track of zeros. Whenever I encounter something which is a 0 in the course of this array, I'm going to swap it with this pointer called I. We are going to do a dry run, and then we are going to see how this works. So once that is done, this is that, and then we will usually do the increment of I++ and J++. Okay, what if ARR of J is pointing to integer 2? It should swap J and K, because K is keeping track of the integer 2. So whatever integer is being held at the position K is going to come to the position of J, and whatever J is holding, which is the integer 2, it is going to push to position K. And then we will increment only K and not J. I'll tell you why. If let's say K was holding a number which is, if K is holding an integer which is 0, if K is holding 0, then obviously in place of J, 0 is going to come, and 2 is already gone back to K. So if that's the case, then 0 should not ideally be in the middle of the array. 0 should be pushed forward. If that's the case, if 0 has to be pushed forward, then this check what we have written, this also needs to happen for that particular element. That is that J, wherever it is, it will stay. It will stay only in case of this condition, when ARR of J is equal to 2. So J will stay wherever it is, only K will increment. So this is condition number 1. This is condition number 2. And finally, we'll have else block. In this, if it is not 0, if it is not 2, then what is J holding? Obviously, it's holding 1. So if it is already holding 1, 1 is supposed to be anywhere in the middle. It need not be pushed to the beginning. It need not be pushed to the end. So in that case, I will simply do J++. That's it. That's the entire logic of this. Firstly, we are going to see this in dry run. Secondly, when we are going to do the code implementation, it will be even more clear. But overall, the pseudocode is something like this. Okay, now let's start with the dry run. Okay, so now let's quickly begin with the dry run. So I and J are at the same position, and K is at the last. So firstly, J is going to check if it is a 0 or it's a 2. So it's a 2, so it needs to swap with K. So J and K will swap. So 2 goes at the back and 1 comes over here. So 2 is over here, 1 comes over here, and K comes back. By the way, I just made this correction. I had written at K++, it was a typo, so it should be K minus minus. So in this case, K will only move. J is going to stay wherever it is. Next, J is already 1. In the next loop, it will check if J is equal to 0 or if it is equal to 1. Since it is equal to 1, so J will move forward. Now it is a 0. So now I and J needs to swap. So 0 comes over here and this becomes 1. J moves forward. Similarly, I also moves forward. So now I is over here, J is over here. J is at 1, so J moves forward. J is over here. I is still over here. Now J is pointing to a 0. So 0 needs to be pushed at the beginning. So so this becomes 0 and this becomes 1. I moves forward and J also moves forward. Again it's a 1, J moves forward. Now it is a 2. Because it's a 2, it needs to swap with K. So what is K holding? K is holding 0. So 0 will come over here and 2 will go over here. And K will now come over here. And this is what I was talking of. If it's a 0, which K was initially holding, so 2 are safely pushed to the back. K has brought along with it this integer 0. So that is why we have to run that check again, whether ARR of J is equal to 0. Since it is, now what will happen? 0, whatever this J is holding, is going to swap with wherever I is. So now this will become 0. This integer will become 0. And what 1 was over here, so 1 will come over here. I think it's looking a bit clumsy, but I hope you get the idea. So once that is done, now again J moves forward and I also moves forward. And this is the point where we are breaking the loop, because the initial, so this entire thing, step number 1, 2, 3, all these conditions are going to run inside a while loop, and that while loop is going to run from J less than equal to K. So the moment J crosses K, while J and K are at the same position, this loop will still run. But the moment J is exceeding K is when this loop is going to break, and that is what is happening. So the moment J comes over here, the loop will break. So now we have all the 2's pushed forward, all the 0's in the beginning, and also the 1's in the middle. So it's sorted. So yeah, that was about this dry run. Now let's see how to make the code change for this. Okay, so now let's start with the code changes. First, let's initialize these 3 pointers. I was equal to 0. J is anyway going to be a part of the loop. So j will also be 0, and this pointer k will be equal to a dot length. Okay, we don't have to do that. We already have the size, so it will be n minus 1. Now let's have this while loop where j pointer is going to run j less than equal to k. Inside this, we will have all the three conditions checked. So we'll say if ARR of j, the first condition was if it is equal to 0, then it needs to swap with I. So then it needs to swap with the I pointer. So we need to have one kind of a swap method where we'll pass this array, we'll pass the pointers I and j. Else if, okay, I again wrote this ARR, A of j is equal to 2, then it has to swap with j and then it has to swap with k. I also have to increment this, so I plus plus j plus plus. And here k will only get incremented, we are not going to touch the j pointer. Else j plus plus. Now let's write this swap method also. Static void swap pointer 1 and pointer 2. These are the two pointers that we need to swap. The same old swapping logic, we'll use a temp variable. Store the first pointer over there. So yeah, that's about this swap method, and that is what we are going to call over here. Again, it's an in-place sorting algorithm, so we are not returning anything. We will try to compile and run this. Okay, we'll submit. So yeah, that was all about this question, sort an array of 0's, 1's and 2's, where we learned this new algorithm, the Dutch national flag algorithm, and we also learned how to write our own custom sorting logic. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people, and if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.